In this video, we will review the final project. The learning objective for this final project is to utilize all of the technical skills that we learned in the course over the semester in order to reverse engineer a product. So the technical skills we've learned is how to create parts in SOLIDWORKS, how to create assembly of those parts, and then how to create a technical drawing. Before you continue with this presentation, make sure to watch this reverse engineering video. It was actually in the final project instructions on Canvas, so if you already watched that reverse engineering video, this is just the same thing. However, this video will give you a background of what reverse engineering is, therefore this project will make a little bit more sense. So next we are going to have an overview of the project, and then later on we'll go into more detail. So for the project, you are going to select a product that you have at home and reverse engineer the product. You will perform a functional analysis, which will allow you to understand the purpose of the product, and then you will disassemble the product while completing a chart while taking the product apart. When you take the product apart, it will allow you to understand how the product works more, and also allow you to measure each of those parts so that you can actually draw them in SOLIDWORKS. And so after you take it apart, see what all the different parts are, understand how they function together, how the system works, then you'll use SOLIDWORKS to draw each part, then create an assembly, and then you are going to create a technical drawing of the assembly. Here are some project constraints. So your assembly must have at least 4 parts, not including screws. When you're actually creating your part files, you don't have to include these screws either. You can leave those out. And then your assembly must have motion. Okay, so part of the project is to actually create a motion analysis video. Therefore, it has to have some type of motion so that you can actually complete that part of the project. And there must be a variety of design between each part. So say that you have a car made out of Legos, but the car is essentially made out of all the same Lego shape. Or a car's not a good example because you need an axle and wheels. So just imagine a house made out of Legos, but you're using the same Legos, then that's not a variety of each part. If you were to do the car example, you could actually do that, or a helicopter made of Legos or anything like that, because you can actually model each part and there's variety. And when you're coming up with your product, make sure to think simple. So the simpler it is, the easier it'll be for you. You don't have to think of some grandiose or grandeur product when you're doing this project. Here is an overview of the timeline. So we have 3 weeks left of school. This final week, 2 weeks from now, is actually going to be the final exam week. But in order to give you enough time, I have 2 things due that week. You can turn them in before also, but let's start with this week. So this week you are going to select your product and complete the project proposal, which we'll talk more about, and that's going to be due actually this Tuesday, and then you'll complete the functional analysis, which is going to be due 2 days after, so on Thursday. And then you will disassemble the product and complete the disassembly chart, which is going to be due on Sunday. Then all of the next week, you are going to draw and assemble, or draw the parts, then assemble the parts, and that's going to be due the following Sunday. And then during finals week, you will create a motion study video and then submit the technical drawing of the assembly. So there's only one technical drawing that you will be submitting, and that's going to be due on Tuesday or May 12th. Right. Here's a breakdown of all of the deliverables that you will be submitting. and the points allocated to each one of these deliverables also shows the due dates. We're gonna go into detail on each one of these things next. So the first thing you're gonna do is your project proposal. In order to do the project proposal, you're gonna have to go around your house and find a product that you can easily take apart and that's simple. You don't wanna do something that has a ton of components and you're not gonna be able to realistically draw yourself. And then on Canvas, you're gonna submit these 3 questions. So it's set up as a quiz. So you'll just start the quiz and answer these 3 questions. So first is, what is your product? Then what does your product do? And then you'll take a picture of the product with your phone or camera and upload that picture to Canvas. That's going to be due tomorrow, Tuesday at midnight, and on Wednesday, first thing in the morning, I'm going to review your project proposals and approve or reject your idea. The reason why I'm doing this is so that I make sure that your product is complex enough, but also I want to make sure that you're not doing something crazy where it's too complex. So make sure to have a backup idea in mind in case I reject your project. I'm going to do that very first thing on Wednesday, so make sure to check on Wednesday to make sure I approve your project. Here is an example of a project. So what is your project or product? And I say I will be using an egg beater for the final project. And then what does your project do? An egg beater is a handheld kitchen utensil with rotating blades used for beating, whipping, or mixing. And then the third question is take a picture of the product and upload it to Canvas. So I actually do not have an egg beater at home, so I found this off of Google. However, for you, I want it to be a product that you have that you can actually take apart, which is part of the reverse engineering process. And then on Thursday, you are going to have Thursday or Friday, you're going to have your functional analysis due. And for the functional analysis, you'll answer these 4 questions. So the first one is, what is the purpose or primary function of the object, which you can use from your project proposal. Then you'll sketch or insert an isometric pictorial, so a picture of the product, and label the individual components. If you're not sure what a particular component is called, then make a logical guess. And then number 3 is explain how this product operates. Use simple machine terminology to explain the operation. And 4, identify the system inputs, intended product function, and outputs. So this is that inputs, outputs table or chart that was shown in the reverse engineering video. I have 2 examples on here. So the first one's of this egg beater. Number 1, the primary function is the same as the project proposal. Then it says insert your picture with labeled, I want you to label the parts. So from what I can see a handle, I can see a crankshaft, I can see blades, and I can see a gear. You can also go in to add hidden parts if you want, because I know there's 2 small gears hidden right here. And then once you take it apart, you can see that the blades are actually not attached to these shafts right here. So it's up to you how you want to do this, but you have to at least label all of these visible parts that you see. Number 3 is explain how this product operates. So I have this one. The egg beater works by rotating the crankshaft with the consumer's hand. So you rotate this crankshaft right here, which rotates the gears. So this crankshaft rotates this gear here. These gears rotate the 2 blades at the bottom. Okay, and so that is how that rotates. This is pretty simple. This is kind of the minimum explanation I want. It would be nice if you had a little more detail in yours. And then 4, the system inputs, function, and outputs. So the inputs is applied force. We apply force to this crankshaft. The function of this is for the blades to rotate, okay, which will in turn mix the food, which is an output. They'll create noise because you hear noise from the device, and also it creates heat because there's friction. So like the video said, almost everyone's will have heat because of friction. Here's another example for a stapler. This one's actually sketched, which you can absolutely sketch your product as well, or you can actually print your product and then label it by hand, just whatever you want. I just want to be able to read it. And on your own time, you can go through and see this example. I just wanted to give you another example in case you needed extra help for this. You can see that this explanation is longer. This is good. And then the system inputs, function outputs are here. So the inputs of our stapler are to staple, or our staples, loose paper, and applied force. Product function is, the goal is to fasten paper, and then the output is noise, heat, and a bent staple. Right. So after you complete the functionality analysis, this is when you're actually going to see if it functions like you thought it did. Maybe when you take it apart, there'll be processes or assemblies that you didn't know were there. So the functionality analysis is an initial analysis, kind of like a hypothesis. This is where you really learn what happened. So you're going to first disassemble or take apart the product. And then while you're taking it apart or after, you're going to complete this product disassembly chart. So in Canvas, I actually attached a Word document that you can fill out, okay? And right here for resource, it actually goes through and tells you how you can use a caliper or ruler to actually measure your design. So right here, I want you to insert front view picture. I want you to insert a front view, take a picture of the front view of that specific part. Say the name of what that part is called, how many. So if there's 2 screws, for example, for quantity, you would put 2 here, and you don't need to actually include the screws twice on the table, just include it once and note the quantity. Dimensions, I know dimensions are going to be hard, do the best you can. Whatever is going to help you the most here for your creating the actual parts, I would be as detailed as possible in this dimensions section. You can also change these columns up and all of that. You can insert a drawing, whatever you want to do for dimensions, just do what will be best for you. The function of the part, so just have a brief sentence or 2 or 3 on how that part functions within your entire part. And then the material. You don't need to be too detailed on the material. I want to know like aluminum, plastic, so you can be simple when it comes to material. Then after you take your part apart, you are actually going to draw each of those parts on SolidWorks and then create an assembly file of the part. You want to, or if we go to the grading criteria for the parts, we want the correct number of parts. So if there's 5 parts, there should be 5 parts and you're submitted. And then if there's a variety of shapes to design parts. So for example, my Lego example, if it's all the same, there's 4 parts, but it's almost the same exact part, then you'll get some points taken off here. For the assembly file, I want your assembly file to show the functionality of the device described in your functional analysis. So you tell us what the point of your product is. I want your assembly file to actually show me how the product works. And your assembly must move, okay? So, or everything should be fully defined if that part does not move, or fixed, not fully defined, it should be fixed, but if it does move, you should not have all of your degrees of freedom taken away. So when you submit this one, you're actually going to submit these 2 together in a zip file. So it should look like this, okay? So egg beater assembly. And then when I open the egg beater assembly, I can actually see here's the assembly and here's all the different part files. So there's 1, 2, 3, 4, 5, 6, 7, 8 parts in one assembly file. And the second bullet point here just states to test your submitted zip folder before you after you submit your assignment. So you don't actually have to use a different computer, but after you submit your assignment, make sure to open it and it works correctly and all of your parts are here, so that when I am grading it, there's no problems. You are going to create a motion study video. So we talked about this in one of our labs, so you should be able to create a motion study, and I believe we did it with the gearbox. You click play, right? So here is an example of what your motion study should look like. We can see that when we rotate this crank or this handle right here, the blades rotate as well. And when you record this, you can use PowerPoint you can use any screen recording method that you want, as long as your output is an MP4 file. And on Canvas, I will actually upload a video on how to record in PowerPoint, just in case you don't know how to record your screen. And the last thing you are going to do is you are going to create a technical drawing of the assembly. So you're going to have one full assembly file, and you're going to create a technical drawing that shows the exploded view and assembled view. I have an example on the next slide. It's going to include the bill of materials with the following columns in the table. So item number, part number, quantity, and material. You're going to include part balloons that will show the part numbers. So I'll be able to match your bill of materials with your actual isometric view, or let me see here. So exploded view actually has these part numbers pointing to it. And then you have to make sure that you properly format and create an ANSI template. We've been doing this for the labs. We've created technical drawings. And the last thing is you want to make sure title block information is accurate. So for example, here's an example of what I want yours to look like. So if I look here is my ANSI template. Here's the title block here. I want your name here. So this has team member 1, 2, 3. Because of the current circumstances, you're not gonna have a team, so just put your name here. Your title, okay, I want you to say Collin College, 1372, final project, Professor Bergman. Your drawing number will be the name of your product, and then make sure your scale matches the scale of these model views, okay? And then here's your bill of materials. This one includes cost. You don't need to include cost. You need to just include these columns right here. You can if you want, but if you don't know that information, then don't include it, right? And here's your part balloons. And that is all for your final project.